Good morning, students. So this is the second video of the function chapter from unit 4 programming C++. So if you have not watched the first video, please watch the first video, otherwise you will not understand this video. So first watch the first function video that I've uploaded. After this you watch this video, right? So today we'll discuss about the properties of the function. So a function has the following properties. Number one is each function must have its own function name. So every function name has its own unique name, and that is the function name is a user defined function name. Function name must begin with a letter or an underscore. It can contain letter, numbers, or underscore. So it must always begin with a alphabet or an underscore, but most preferably we use alphabets to start the function name. So it follows the same rules pertaining to the variables. So it should always start with a alphabet or an underscore, and in after that you can contain more letters or numbers or underscores. Now each function name has parentheses following it to differentiate functions from variable names. So the all the function name is followed with this parenthesis, so this denotes that it is a function. Body of function must be enclosed by braces, that is opening and closing braces. So this whatever is written within these braces, it is the body of the function. So it may contain one or more block of statements. So it may contain a single statement, or it may contain two, three statements, that is compound statements, right? So these are the following properties of the functions. Now function returning values. So in the previous program, or in the previous video, I have explained one program, that is sum of two numbers, where the call function name was sum underscore num. So the return type was void, and the function did not pass any arguments or did not uh, declare any parameters. So the calling function did not return any value from the call function, or the call function is also called as the function definition or receiving function. So the calling function calls the call function, right? And then in that previous program, the calling function did not receive any value, from the call function. So in this video we are going to see two programs where you will see that the call function does return a value back to the calling function. So in the previous program we saw that in the function definition sum underscore num, in the function body, in the function definition body, the variables were declared, the formulas were executed, sum equals to a plus b, and the cout statement was run in there. So no value was returned back to the calling function. So now it is possible to pass values from a function called, that means from the call function to the calling function, using the return statement. So if we use the return statement, then from the call function we can send a value back to the calling function. So we have to use this return statement. So to return a value from the call function to the calling function, put the return value after the return statement. So here the format. So this return statement, the format is this. So the return keyword, okay, and within the parenthesis the return value. So the return value may be represented by a variable. So since the variable stores the value, so when you are returning the variable, you are returning the value or the argument that is stored in the variable. So here the parenthesis is optional to put. So you can write return like we used to write in every program, return 0, right? So return 0 and no parentheses are put, so it is optional, but always it is a good programming practice that to let the user or other programmers know that by using this parenthesis, clear? So it differentiates, so it tells the programmer that okay, within the parenthesis, that is the return variable, or that is the return value. So in return 0 also we can use this parenthesis, return 0, and within the within this parenthesis we can put the 0, but it is optional. So mostly we write return 0 without the parenthesis, but in terms of the calling function and call function, it is preferable to use the parenthesis. Clear? So here the return type of function specifies not this return type. Okay, this is a return statement. This is a keyword which through which the call function will return a value to the calling function. When we talk about the return type, we mean the return type of the function name, right? So here this is the function name, the user defined function name, and this is the return type. So it specifies the type of value returned by the function. So this tells the compiler that this function will return a float type. So here you can see that in this example, the return type of this function is float. Within the parenthesis, there is the parameter type and then the parameter name. So this parameter name n is a user-defined variable or a parameter name. So it stores the argument integer value. So this variable stores integer value, but when this function returns the value, okay, so the value will not the value that will be returned will not be integer value, but it will be float value, because the return type has a higher precedence level over the return type enclosed within the parenthesis. Clear? So now let's look at a C++ program where we use the return statement, right? So here this program is to convert Celsius to Fahrenheit using the function prototype. So as you can see here, it starts with a header file, and this is the function prototype declaration. So here this is the return type, this is the user defined function name, that is convert, and within the parenthesis you have float C type. So this is the parameter type and this is the parameter name, or you can say this is the variable data type and this is the variable name, right? So actually the function prototype is acts just like a you can say as a template for the calling function and the call function, because based on this function prototype, the name of the calling function, the calling function, the parameter type, the parameter name, and you can see that the call function also, the return type, the function name are same, right? So function prototype acts as a template for the call function and the call function, so that it will have the similar name, the similar return type, and the similar types of parameters. So you can see that here this function will return a float value, that is decimal point value. Now within this, since this is a user defined function name, okay, the name of this function actually does not matter. You may write here, instead of convert also you may write a different name, but the function will execute as it is. So the purpose of this within this parenthesis, this function will accept the value which is stored in this variable, okay, and it will return it as float type. So you can see that this, so since this is a variable, it must also be declared, right? So all the variables must be declared, so this variable is declared as a float type. So as you have seen in the previous video, the usage of the function prototype, so it tells the compiler the return type and then the function name and then the parameter type, the parameter name, right? It also prevents error mismatch. Suppose like here you have in the function prototype you have written convert, so let's say in the calling function you have misspelled it, convert to say COMVERT, and here also so instead of convert you have written convert, right? And let's say here the return type of this function, instead of float you have written int. So there is the return type mismatch. This is in function prototype it's float, here it is int, and the function name is convert, but here suppose it is convert, right? So the compiler will return error. Clear? So that is the use of a function prototype. So it is usually written after the header file before the main function. So you can see in this particular program the main function is written first, and then the other module or the other program subprogram is written second. So it does not matter if you write down the main function below this also, right? Because the program execution will start from the main function. So by default the main function returns an integer value, which is return 0. 0 is an integer value, right? which signifies successful termination of the program. So here always remember that in the main function, okay, it is possible that when we dealing with this function chapter, that the calling function must always be written in the main function, clear, because the compiler will execute only what is written within this main function body. So you can see that this program is split up into two programs or two modules. That is, one is the main function body, and the other is this function body. So this is two program, okay, but however it is connected with the main function by the calling function. So using the calling function, we can execute this other program by using this calling function and this call function, clear. So inside the main function, you can invoke the calling function, okay. You can declare variables, you can assign the values to the variable, clear. But you cannot execute the formula here, because if you execute the formula in the main function, okay, then there is no need of this calling function and call function. So the formula is always executed in the call function, that is in here, which is outside of the main function. Always remember that the call function is written outside of the call function. Otherwise, if it is written inside the main function, there is no use of the calling function and the call function, clear. So here you are declaring two variables of float type, because we want the return value to be of float type, right? So based on that, we are declaring two variables, that is Celsius temperature and Fahrenheit temperature. Since the program is to convert Celsius to Fahrenheit, so this Celsius temperature will accept the Celsius value from the keyboard, and this Fahrenheit temperature will, when it is converted, will store the converted value, that is in Fahrenheit format. So this variable is declared, clear. So after the variable is declared, we have to enter the value, right? So in the main function, we can input the value. So here, cout, what is the Celsius temperature to convert. So from the keyboard, it will be stored in this ctemp, right? Now after that, the next step is to execute the program logic, right? Always it's like input, process, output. After inputting the value, we need to process the input values, that is execute the formula, right? So since here lies the problem. You have entered the value here, right? In this part of the program, you have entered the value here. The compiler will only execute within this opening and closing bracket. So the formula is here. The conversion from Celsius to Fahrenheit formula is here. So how will when you have entered the value here, suppose like 30, ctemp you have entered 30, so the input value 30 is here in this part of the program, and the formula is here. So you need to enter the 30 value here, right? So 30 into 9.0 into divided by 5.0 plus 32.0, right? So you need to execute this formula. But if the input value is here and the formula is here, how can you transfer that value to here? So only then you can process this formula, right? So you can only then, only if you enter the value here, input the value here, then you can process this program logic. So how can you transfer that value from here to here? So the answer lies with the calling function. So with the calling function, what two things that you can do using the calling function, okay, using the calling function, you can call this call function, you can call the other part of the program that is outside of the main function, and using the calling function, you can pass the values that you have entered to the call function, clear. So here you can see that convert ctemp, so this is the calling function, okay, it is ended by a semicolon, always remember that. So within the parenthesis, okay, what this function does is, this function, okay, because the compiler knows that this parenthesis means that it is a function and this is the function name. So the compiler, okay, what it will do is that ctemp means you have entered suppose 30, so you are passing the value 30 here, okay. So this function is passing the value that is stored in this ctemp to the call function, and it will be stored here. So in the call function also, okay, you must have another variable, which will accept the value from here to here, okay. So the variable that is declared here ctemp, okay, and this ctemp, these are not same, okay. this ctemp this ctemp variable ctemp is declared in this program, okay. So this is separate program, this is separate program, okay. And this float ctemp, though it looks same, okay, this is not this variable. So this variable ctemp is a different variable which is used in this program only. Clear? So as you know that when you are passing the value of from here to here, okay, uh, you need a variable to store the value, right? So here in the call function, as you can see that the call function is similar to the function prototype. So in the calling function, you do not write down the return type of the function, but always in the call function you mention the return type, the function name, and then the parameter type, and then the parameter name. So as you can see that here the variable which is accepting the value from here to here, from the calling function to call function, the data type is same, float, okay. So the here the variable name, instead of ctemp you can also write, suppose like you can write temp only, okay, not c underscore temp, but if you write here temp, temp, okay, the that this that variable temp will accept the value which is passed from here to here, okay. So by that you can understand that, okay, the name of the variable does not matter, okay. What matters is in the when passing the value from the calling function to the call function, okay, what matters is based on the function prototype, okay, the return type, okay, the return type or the data type of the parameter, it matters, okay. It should be same. If this parameter type is, or if this variable data type is float, the in the call function also the variable which is accepting the value should be of float type. So this, it cannot be int. If you write here int ctemp, okay, whatever value is passed from this float value, suppose like 30.0, okay, it cannot accept this value, so it should be float. Clear? So that's why in the function prototype it is declared as float. So based on that, okay, from the calling function also the float value should be passed, and in the call function also a float value should be accepted, not an integer value. Clear? So it does not matter the name of the parameter, the name of the variable, if it is different also. Here it is c underscore temp, and if here it is temp only, temp, then that also it is okay. Only thing is that the data type should match, float. Clear? So this variable and these variables are different because it is written in separate programs, okay. So here this is the calling function which will pass the value, and you can see here this calling function is assigned to another variable ftemp. Because why is because we are returning the value in this program, we are returning the value from the call function, from the calling function, from the call function to the calling function, okay, from the calling function to call function, because the cout statement, the output value that is to be displayed is in the main function, that is below the calling function, right? So we have to display the final result in the main function, that is the Fahrenheit equivalent of Celsius is ftemp, right? So here that's why this variable is uh, assigned to the calling function, so that whatever value is stored in here will be stored in will be assigned to this variable ftemp, and then you'll get the output value, okay, and then that value will be displayed, and then the program will terminate. Now once this value gets passed from here to here, okay, to the call function, so the as you can see that the call function and the function prototypes are same. So here in the call function the variables are declared, so the variables needs to be declared so that the value that is passed, the float value that is passed, will be accepted here. Clear? So the function definition also does two things. It accepts the value that is passed from the calling function to the call function, that is it the call function, it accepts the value that is passed from the calling function, and it the call function also declares a variable, or could be 2-3 variables also within this function definition parenthesis. Clear? So now here another variable is declared. So because now we need to return the value after executing this formula, right? So another variable ftemp is declared, and this variable ftemp is not same to this ftemp here, because this ftemp is declared in here and this ftemp is declared in here. So even if you write here, suppose like float, okay, and you just write here temp, okay, so this ftemp and this ftemp are not same. Clear? So here, after executing the formula, since it is a float value, right? So that's why it is written here 9.0, 5.0, 32.0. Clear? So after executing the formula, the value will be passed to this variable, and then it will be assigned to this variable, and then using the return statement, since the value is stored in this variable, so that variable name will be written here inside the parenthesis of the return statement. Okay, so that value will be returned back to the calling function. Okay, suppose let's say you get the value 33.0. Okay, so this 33.0 will be returned back to the calling function, because the calling function, okay, the calling function calls this call function, right? And then the call function is returning the value. So this value 33.0 will be returned back to the calling function here. Okay, and in the place of this calling function name, that value 33.0 will be written here. Okay, and that value 33.0 will be assigned to this variable ftemp, and then finally the next statement will be executed, that is cout. The Fahrenheit equivalent is, that is ftemp, that is 33.0, and then the program will terminate. Clear? So always remember that. Okay, in the main function you can declare the variables, you can enter the values, and then the calling function needs to be declared in the main function. And then in this program you can see that the call function is able to return a value back to the call function. Clear? So when the call function is returning a value back to the main function or to the calling function, okay, be sure that, okay, the output statement, okay, to be displayed will be written in the main function. Clear? So now let's see another program, which is to calculate the average of three input values and then return the average using the return statement. So from the keyboard, three input values will be entered, and then we'll calculate the average of that, and then using the return statement, that value will be returned back to the calling function, that is to the main function. Clear? So here we have declared two header files, iostream and then iomanip, that is input output manipulator.h. Now this header file is used because we are using this set precision keyword. Okay, so what this set precision does is, since here also the return type is float, okay, so that means decimal point value. Set precision 2 means, okay, when the output value is displayed, okay, the suppose like 32.57, okay, 32.57. So you can see the set precision 2 means, okay, after the decimal point, okay, two values will be displayed. Clear? That is 32.57. If suppose you write here set precision 4, okay, then it will display 4 values after decimal point. Suppose like 34.4567, like that. Clear? So that is the use of this keyword set precision, and within the parentheses we mention the number of values we want to display after the decimal point. Clear? So for that we use this iomanip. If you don't include this, the compiler will not recognize this set precision. Clear? So here it starts with the function definition. So this is one part of the program. Okay, this is one part of the program, and this is another part of the program. So this is the function definition, that is the call function, and this is the main function body where the calling function is written. So when the program starts executing, it will start here, right? And then here you can see that since we have to input three values, so we declare three variables, that is int, that is of integer type, num1, num2, num3. Clear? So num1 will store one value, num2 will store another value, num3 will store another value. So here num1, num2, num3, as you can see here, also in the function definition, it is declared int num1, int num2, int num3. But this num1, num2, num3 is not same with this above num1, num2, num3. Clear? Because this is a different function, this is a different program, and this is a different program. Clear? So now you are declaring the variables here, and then you are declaring another variable that is a float type and assign the value 0.0, which means that this is to hold the return value. Clear? Now uh, normally you can also declare straight away, declare like float average semicolon. Okay, but here you this variable average is assigned the value 0.0. Okay, this is just to show that, okay, this is just to show that this variable will store decimal point values. Okay, so that is why it is written here 0.0. If you don't write here this equals to 0.0 also, okay, and if you just write float average avg semicolon, okay, it will not show any compiler error. Clear? Because here straight away the value is assigned to the variable avg, right? So now this variable is declared so that, okay, the value that is returned from the call function to the calling function, okay, will be stored in here, and then you get to display the output value through this avg variable. Clear? So now if suppose, okay, like here is an example, this float avg, okay, and this local avg, okay, that is float local avg equals to 0.0, these are not same. Now if suppose I write here, instead of this float avg, if I write like this, float local avg equals to 0.0, okay, like I said, this variable local avg and this variable local avg are not same. Okay, because it is declared within different function body. Okay, so after declaring the variables, next step is to enter the value, right? So using the cascading operators, we start entering the values for num1, num2, and num3. Suppose it is like 10, 20, 30, so it will be stored in 10 here, 20 here, and 30 here. Okay, after entering the value, the next step is to process the formula, right? So since the formula to be executed to find the average is in this function body, okay, so using the calling function, okay, this is the calling function. So this calling function, okay, and within the parenthesis we are writing down the name of the variables num1 comma num2 comma num3. So in the previous program, using the calling function, we pass only one value, that was which was stored in the variable ctemp. But here, since we have declared three variables and we have entered three values, right? So it is possible for the calling function to pass more than one value, right? So here num1, num2, num3, these are the parameters, okay, and it will pass this, using these parameters it will pass the arguments or the values which are stored in num1, num2, and num3. Clear? So using the calling function, the value 10, 20, and 30 will be passed from here, okay, to this variable int num1, num2, num3. Clear? So here this is the call function, or this is the function definition. It has its own function body to be executed, right? So as you can see that, okay, the return type of this function is float. The function name is calculate av, which is same. Here I've made a spelling mistake. Okay, here also it should be calculate avg, okay, as I've written here, calculate avg, right? So here also here it should be avg. Clear? So the function name is same. So here what happens is the value that is passed by the calling function 10, 20, 30, okay, will be accepted by the call function and stored in this variable int num1, int num2, int num3. Okay, so here we cannot write down here int num1 comma num2 comma num3. All these variables have to be declared separately by its data type, because later on you will know that, okay, the parameters that are declared in the, or the parameters that are passed by the calling function and the parameters that are uh, declared in the call function, okay, the data type of the parameter could also be different. Suppose like here is int, here is float, and here is character. It can be like that, or it can be int, float, int also. Okay, so every variable should be declared with its own data type. Clear? So using the call function, two things as I said happens. It accepts it the calling function, okay, calls the call function to execute the function body, okay, and then the call function, okay, it accepts the value, that is passed by the calling function, okay, and then the calling function, the call function, okay, declares a variable or three variables, okay, or number of variables to accept the value which was passed by the calling function. Clear? So now after the values are accepted, the next step is to execute this function body. So in this function body also we are declaring the variable local average, which will store the average value that is executed, okay. So here local avg equals to, okay, num1 plus num2 plus num3 divided by 3. So this is the average formula, okay. So here within this parenthesis you can see that I have written here float, right? So this is what is called as type conversion, which you have learned in the previous chapters, right? So type conversion or typecasting. Now, why this type conversion or typecasting is used? Because here the variables num1, num2 and num3 are storing integer values, right? So when we use typecasting, that is here it is float. So what happens is the value that is stored in num1, suppose 10, 20, 30, okay, will be temporarily converted into float value, that is decimal point value. So it will be 10.0, 20.0, 30.0, okay. So by using typecasting, you are temporarily converting the integer value to float value, so that you can execute this formula correctly. And then because the local average, okay, the local average variable is a float type. So when the formula is executed, okay, instead of getting suppose like 10, okay, 10, so 10, that variable value 10 you cannot store in this local average because it is float type, right? So when you use this typecasting, it converts the 10 to 10.0. So local average will store the value 10.0 instead of 10, okay. But even in this particular program, even if you don't use the typecasting, okay, by default, okay, an integer value will be converted to float value, okay. But when you suppose like the local average is integer and this int num1, num2, num3 is of float type, okay, then in that case we have to use the typecasting, because a float value cannot be converted to an integer value. If we try to convert a float value to an integer value, okay, some random garbage values may be assigned to this int local average. Clear? So in that case we have to use typecasting. Clear? So for this particular formula, even if we don't use this typecasting, okay, by default the integer values after execution of this formula, the value 10 will be converted to 10.0 and stored in this variable local average. So now after the value, after we get the after executing the formula and after we get the value, as we have to use the return statement, so using the return statement, the value that is stored in this variable, okay, the call function returns a value to the back to the calling function that is here, okay. So instead of this calling function name, the value suppose like 10.0 will be sent here, and that value will be assigned to the variable avg. And so cout will execute this string statement and then will display the value, suppose 10 point, okay, 0 0, since the set precision is 2. Clear? And then the program will terminate, return 0. Clear? So always remember that when we have a return statement, okay, the output will be displayed in the main function, okay. So students, go through these two programs very nicely, okay, try to understand the program logic, okay. This function chapter is very important, okay, because every program, every topic will show a different means like in every program there will be a different topic to be understood. Clear? So you have to go through all of these programs and all of these topic one at a time. Clear?